So we know that 2 squared is equal to 4. We know that 2 to the third equals 8, and so on and so on. So we know how to do this mental math question when I ask you 2 to what power will give you 16? Right? Now, as an equation, it would look like this. 2 to what power, use the variable x, will give you 16. So 2 to what power gives you 16? Huh? 4. There you go, 2 to the 4th, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So using mental math, we know that the answer is 4. But what if I asked you 2 to what power gives you 6? Then mental math no longer cuts it. Because you're thinking, okay, 2 squared is 4, 2 to the third is 8. Wait a minute. 2 to what is 6? It's just, it doesn't cut it. And this is when we need logarithms, right? So if they did ask you 2 to the x power equals 6, we would set it up as x equals log base 2 of 6. I know that right now doesn't make sense, but it will. Let's first understand our key concept, what we need to memorize, what we need to know. And the key concept is this. Log base b of y equals x. Okay? So we need to know how to read it first. It's log, and you always say the word base right before reading this little number. Log base b of y equals x, and use the word of right before this one. Okay? So there it is, how to read it. Log base b of y equals x. Now, that's just the position of the numbers, and this is true if and only if b to the power of x equals y. Okay, I know this sounds really confusing. It's really just a matter of rearranging the numbers, right? So this little number that was on the base of the logarithm is going to move over here to be the base of your exponent situation. The answer x is going to become the exponent on that base, and this number that was with the word of is going to be your answer over here. So what happens is we're going to take this logarithmic situation and rewrite it as an exponential situation. Or they might ask us to take the exponential situation and rewrite it as a logarithmic situation. So I know that sounds confusing right now with letters. It becomes easier when we actually see some examples. But before that, let's talk about some vocab words. Common logs. Okay, common logs have the base 10. So if there is no base on the logarithm, you have to assume that it's base 10. So for example, if I give you this problem, log 100, okay, if I give you that problem, log 100, you have to automatically assume that this base right here is 10. Even if they don't write it, you automatically assume that it's base 10. So how would we read this? We would say log base 10 of 100. Or another way of reading it with the vocab word, say common log, which means log base 10 of 100. Common log of 100. Right? Or you could say log base 10 of 100. It's kind of like when you have a variable x. Like if I say, what's your answer? 3x take away 2x. What's the answer? It's x, right? Now, you could put the invisible 1 right there. You could put 1x. That's totally fine. So on a logarithm, same thing. Like if you have log 1,000, you could put the 10 down here if you want, but it's not necessary because when you don't have a base, you automatically assume it's a base 10. That's called a common log. So just like up here, you don't need the 1. Down here, you don't need the base 10. But if you want to, you could write it. It's totally fine. Make sense? Yes or no? That's what a common log is. Okay, so let's move on to natural log. A natural log is when you go to the restroom and, okay, that's not even, sorry. Gross. Bad joke. Stop it. A natural log is a logarithm with base e. Once again, a logarithm with base e. Okay? So check it out. Log base e of any number can be rewritten or is usually written as ln of a number. Okay? So let's say I have log base e of, let's say, 5. Instead of writing log base e of 5, you could write it as ln of 5. It's the same exact thing. Log base e is ln. ln is log base e. And that is called a natural log. Okay? So even instead of saying log base e of 5, or instead of saying ln of 5, you could also use the words natural log of 5. Natural log implies log base e. Okay, so those are just the vocab words that we need to get used to. Common log is any log base 10. Natural log, any log base e. Now let's actually understand how logarithms work. You see, a logarithm is really the inverse of an exponential. And an exponent is the inverse of a log. Okay? So if I asked you, what is log base 2 of 8? The answer is 3. Okay? But let's think about the reason why. In exponential form, this base 2 would be the base of the exponent. So you would say 2 to what power gives me 8? See, that's the exponential form. So when you see this problem and I ask you to simplify it, you got to think, okay, the base on the log, that's really going to be the base on my exponent situation. And then I got to think 2 to what power gives me this answer? 2 to what power gives me 8? The answer is 3. Does that make sense? If I were to just give you this one right here, I know you can see the whole thing on your paper, but let's pretend that you don't see the whole thing. Let's pretend that it just said log base 4 is 16. Okay? Well, you got to think, okay, 4 is my base on my log, so 4 is my base on my exponent. So 4 to what power gives me 16? 4 to what power gives me 16? 2. That's why the answer's 2 over here. Right? It's really that easy. How about this guy? 5 to what power gives me 1? 5 to what power gives me 1? The answer is 0. Because 5 to the 0 power, anything to the 0 power equals 1. Does that make sense? Yeah? Now, right there I'm explaining how to simplify it. And the how comes from understanding how to rewrite an exponential form. So on this first one that we actually did, we said 2 to what power gives us 8? The answer is 3. This is what we came up with. 2 to what power gives us 8? That's exactly the exponential form of it. If you look over here, 2 to what power gives you 8? 3. So you would write 2 to the third power gives you 8. Okay? And see, this rewriting from logarithmic to exponential comes from this most important truth that we learned up here. Okay? Once again, the base on the logarithm is going to become the base on your exponent situation. The of part, the number, the of this number, that of number becomes the answer over here. And the answer here becomes the exponent here. So whenever you have the logarithm of something, you're going to think log base something of this. You're going to think b to what power gives me y? B to what power gives me y? And that's exactly what it is over here. B to what power gives me y? Let's go back over here. So 5 to what power gives me 1? The answer is 0. 5 to the 0 power gives me 1. This right here, guys, is what kind of log with the vocab words? Common log. Why is that? Because I don't see a base right here. So you could automatically assume that it's a 10, log base 10. So if I ignore the answer, and if I were to give you this problem, I'd be saying 10, the base, to what power gives me 10? 10 to what power gives me 10? The answer is 1. 10 to the 1 power gives me 10. Okay? And that's what it is over here when you rewrite an exponential form. 10 to the 1 power gives me 10. Okay? And on this last part, what we've been doing, the whole pattern, b to what power gives me y? B to this power will give me y. And that's exactly what we're supposed to learn. B to the x power gives me y. It's really just rearranging the numbers. Once again, the base here becomes the base there. The of number part here becomes the answer over here, and the answer here becomes the exponent on your base right there. Okay? So, this is why when I ask you, evaluate log base 8 of 64, the answer is 2. Why is that? Well, because if you're just looking at this, log base 8 is 64, what we're really saying is 8 to what power gives me 64? And what's the answer? The answer is 2, right? The answer is 2. Because we know how to convert the logarithmic form to exponential form. Okay, logarithmic form to exponential form. Does that make sense? I hope so. Jumping to the top part over here, it says calculating logarithms using a calculator. So on the calculator, you could do logs. There is a log button. Let me show you the log button. It's right here. Right there it says log. So if you hit log, it'll actually pop up on your screen, and you could type in whatever number you want to take the log of. But the thing is, this log is base 10. The calculator only does base 10, unless you have a graphing calculator or a more powerful calculator that could do different bases. But this log button on the TI is base 10, okay? And this other one over here, also the log button, which is right there, is base 10 as well. So you could do log base 10. So check this out. If you have a calculator, right now if you did common log 100, if you typed in log and then 100, that would give you the answer 2. Now why is that? Because common log 100 is really log base 10 of 100. Log base 10 of 100, let me write that down. Log base 10 of 100, that's really, if you think about it, this base right here is 10. That's really common log, base 10, and the calculator does common log. So that's really saying the base to what power will give you 100. Well, the answer will be 2. So if you did type it in on a calculator, log of 100, common log of 100, you will get the answer 2. Let's say with this calculator, how about we do common log 10,000. Now, how about this? Even without the calculator, let's use what we know already. The base is 10, so you're really going to say 10 to what power gives you 10,000. Now, 10 to the second is 100. 10 to the third is 1,000. 10 to the fourth must be 10,000. So just by knowing that, I know that my answer is going to be 4. Go ahead and do it on a calculator. Type in log, type in 10,000, hit equal. That's common log 10,000, hit equal. You should get the answer 4. Yay? Okay, so are we understanding logarithms? Now, these calculators don't do log base 3. They don't do log base 4. They don't do any other base except base 10 and also base E. Remember, the LN button right here is really log base E, right? It's the same thing as log base E. So it does do log base 10 and it also does log base E. But it doesn't do base 2 or base 3. So that's as far as the calculators take us. What we're going to do right now, instead of continuing on with these notes, we're going to jump to the back part of this so we could work on some examples of the stuff that we've already covered on the notes. And I'm actually going to pick this up on the next video. So let's flip the papers over. If you're at home, jump to the next video and you'll be on the back side of this worksheet.